Hello, and welcome back to another episode of Low Spec Labs. Let's go ahead and get started. So, Chapter 8 of the RHCSA exam book talks about configuring networking. This is a long form video of some other videos I've already released. So, if you've already seen those videos, you can go ahead and skip this. I don't want to waste your time. It's the most precious human resource of all. So, if this is a waste of your time, skip it. If not, tune in and have fun while we educate ourselves on some Linux networking topics. Let's go ahead and get started. Hello, and welcome back to another episode of Low Spec Labs. Let's go ahead and talk about Linux networking. This is a combination of your favorite topics and one of my favorite topics. I don't know why you guys are obsessed with networking stuff. It's very dry and boring. But hey, give the people what they want while also doing what you want as well. So the very first thing they talk about in Chapter 8 is IP addresses, what they are and the different classes of IP addresses. I'm going to go ahead and let Past Steven handle this. He's taking a visit from my YouTube channel. So before we continue on the rest of these videos, we have to talk about another fundamental concept. What is an IP address? An IP address is a protocol or a set of rules that defines different ways to identify a computer on a network, whether that network is public or private. In short, the fancy numbers below me are simply something like your postal code, right? The very first part of that number could be considered your country. The second part could be considered your state. The third part is your city. And the very last part is your actual, address. So that was the basics. Let's dive a bit more into detail into what an IP address is. All right, so let's explain the IP address a little bit more in detail. So an IP address is four numbers or four sets of numbers separated by dots. Each set of these numbers has 8 bits, and overall, all the bits have 32 bits total. An IP address also has two parts, the host ID and the network prefix. So how do we determine which part of the IP address is the network prefix and which part is the host ID? Or there's another piece of an IP address called the subnet mask. So let's remember the subnet mask has 8 bits. The 8 bits of the subnet mask will represent numbers between 0 and 255. These 8 bits in the subnet mask define which portion of the IP address belongs to the network preface and which belongs to the host. So basically, it tells you which part of this network is like your country, city, state, and which part is the actual home address of the host itself. And there we go, boys. We just went over some fundamental networking knowledge there. That's some pretty easy stuff. I hope you were able to keep up. If not, Google is your best friend. If you want to be an IT admin, you should get very familiar with Google Foo. All right, boys. So now that we've gone over the boring theory part of the chapter, let's go ahead and start the practical side where we learn how to use different commands. What is the IP command? On Linux, the IP command can be used to view your IP information, to set your routing information, as well as to check your network state and see if the link is even up. Let's dive into how to use that tool. First things first, you're going to want to log in and elevate yourself to root. Generally, you can't mess with network configuration settings unless you're at least an administrator. So just make yourself root to make things easier. So what if we wanted to see the status of network connections on a host we just connected to? We could do IP-ec link show. And as you can see, it gives us the physical interfaces. And it shows us how much data is being transferred over this interfaces. You see, it shows us the amount of bytes received, the amount of bytes sent, and then also shows us how many of those bytes got dropped right here. So this is a good way for you to test the actual physical interface to see if you might have a problem, like with your network card or something. What if we wanted to actually view the IP information, like the IP address? Well, to do that, we'd do IP address show. And as you can see, it gives us the IP information. It gives us the IP address itself. It gives us the interface it's tied to, which is right here. It even gives us its MAC address right here, right? So if we wanted to, let's say, just view the MAC address of that interface, we could do IP address grep link
There we go. Remove the extra space because it's looking for the space after the character. But as you can see here, underneath link/ether, we can actually see the MAC address of that interface, which is the same thing as if we were to scroll back up, and you can see right here, link/ether ENS18. We see that MAC address again. Hello and welcome back. Let's go ahead and talk about routing. So what is a route? A route is effectively a map on how to get network data from one network to another. When you're working with Linux systems, you're going to have what is called a routing table. How do we view the routing table? Well, we do IP route show. And as you can see, it lists two routes. The first route is called default. This is normally pointing to the internet. And as you can see, it says to get to the internet, we have to send all traffic that is not on our local network to 10.0.21. The second route listed there is for our local network. Basically what this says is that all traffic destined for 10.0.20 heads out interface ENS18. So it heads out of our single interface we have attached to this host. All the routes on your system are in what is called a routing table. How do you view the routing table on a Linux host? You do netstat.rn. and you'll see it lists the routes. It's basically the same thing as IP route show, but in a more usable format. You see it shows the interface it's assigned to, it shows your gateway, it shows the destination, it even shows you a mask for those networks as well. Very useful information. I guess I lied. We're doing another theory video. Well, theory and lab, this will be pretty quick. What is a port? Ports are virtual places within an operating system where network connections begin and end. Basically, ports are a way to identify and track network connections of different services on your network. They're very useful. Let's go ahead and dive into how to view them and some common ones you're probably going to need to know about when you're troubleshooting Linux systems. The thing you should remember is that any service can run on any port, but it's generally suggested that you stick to the standard ports to keep things simple for yourself. How does one view what ports or connections are currently active on a Linux system? Don't worry, I've got you. To view the active connections on your system or to list all ports your Linux host is using right now, we do ss-lt. To remember this, I remind myself SS like the Nazis. So when we do ss-lt, you'll notice we have 000, and it lists the port right there, which is SSH, and we have IPP. So we have two services on this host that are currently running, SSH for our SSH server, and I don't know what IPP is, but I'm pretty sure it's pretty important. Time for a lab, boys. I hope you're keeping pace. This is going to be fast. This is lab 8-2, verifying network settings on a Linux host. Let's get started. Step 1, log into your host and elevate yourself to root. I've already done that. Step 2, we then have to verify our routing information. To do that, we do IP route show. So you can see it lists the default routes on our host. They then want us to ping Google's DNS servers. To do that, we do ping 8.8.8.8. And as you can see, we have an internet connection because it's hitting Google's DNS servers. Look at that. After that, we're going to use an IP address, grepnet. Let's spell grep correctly. All right. And as you can see, our IP is 10.0.21.3.8. They want us to add a new IP address to that. Let's go ahead and do that. So to add an IP on the command line, we would do IP address add. We then enter the address. So that's 10.0.20. I shall call this 141. And then we enter our subnet, which is /24. And then we enter device. And then we enter the device name, which for this would be ENS18 right here. And then when we do net, you'll see we now have two IPs listed on this host. We have the first one, which is listed here. Then you can see we now have a second one that's also listed here as well. Look at that. Yes, a single interface can have multiple IPs. This is useful in very specific scenarios, or if you're setting up like failover or other stuff like that. And finally, they want us to list active ports on this server. So to do that, we do ss-ult, right? And if you notice, we use the U command. If you're eagle-eyed, you'll notice we added one extra flag to the SS command, the U. Basically, U is for UDP, T is for TCP, and L is just to list the ports themselves. You can see we have both TCP and UDP ports listed here. And that's it for that lab. On Linux, there's about 3 or 4 different ways to achieve any task you want to achieve. Why is that? The reason for that can be explained in an XKCD meme. Look at that. How standards proliferate. Situation, there are 14 standards. Someone decides they can create a better standard, and now there are 15 standard. Because Linux is open source, the acoustics with power levels higher than mine all decide they can re-implement industry standards better. Sometimes they do, sometimes they don't. That's why there's like 4 commands to change your IP address on Linux. In the last video we talked about one of them, IP address add. IP address add is old, probably older than me. There's alternatives to it, much newer, fancier, sexier alternatives. Those 2 are NMCLI and NMTUI. One of them is a command line utility. The other one is a text UI. Let's dive into how to use them. Of the 2, I suggest you just use NMTUI. It's a lot easier. NMCLI is very useful though. Let's dive into some of its features first. We start with NMCLI con show. NMCLI con show. And basically that shows us all current active connections. You'll see we currently have one device called ENS18, and then we have a loopback interface, which is basically how the server finds itself. Now let's try that but with NMTUI, and you can see we get an actual menu. So this is a lot easier to use. So if we wanted to edit a connection, we could go in there, and you can see we have our actual interface, and we can go back, we can activate a connection and deactivate it back. We can set a host name, all very useful. So if you want to change network settings, just use NMTUI. Save yourself the time, the effort, and the mind power. Let's go ahead and get started with Linux Labs 8-3 and 8-4. We'll start with 8.3, how to use NMCLI. We kind of went over that in the last video, but this is a very complicated command to use. We're gonna play with it a little bit. Step 1, go ahead and log in as root. We've already done this, so congrats. You're about to see why I suggest you use NMTUI instead of NMCLI. So if you wanted to use NMCLI to add an interface or like a DHCP to your network interface, this is the command you'd have to use. Now I'm not sure about you, but I'm going to mess that up. And I'm not going to be able to recall that from memory. For instance, it says NMCLI con add, con name, DHCP, type, Ethernet, IF name, ENS18, IPv4 method auto. So basically what we're doing is we're adding a IP address to interface ENS18 and we're assigning that via DHCP. And with that is successful. That's how you add a dynamic IP using NMCLI. How do you add one using a static IP? Well, we can do the same thing, but change a couple variables. And if you wanted to statically assign an IP address, you would use this command, NMCLI con add, con name static, IF name, ENS18. So we're creating a static interface named static. We're assigning it to ENS18, and then we assign an IP address, which is 10.20.142/24, and we assign a gateway, and then we also tell it that this is a manually assigned IP address. Now again, I wouldn't be able to remember that if I was in a high pressure situation and I had to change some network settings. So then we got to view the changes we just made. To do that, we do NMCLI con show. And as you can see, we now have a couple of different connections. We have 2 DHCP connections, 1 static connection, though these are not assigned to an actual interface yet. So now that we've walked through that NMCLI lab, don't use that command. Take all that information and flush it from your brain. That is a waste of precious mental resources. Your mind is your most powerful tool. Don't waste it learning not very useful things. Use NMTUI instead. Let's get started. First things first, like always, go ahead and log in as root. We like to be an administrator to change network settings. After that, we go ahead and do NMTUI. And then let's edit a connection. You see, we have a bunch of these. So the first thing we want to do is delete these connections. delete, because we're not using them. Delete, and then static, delete. So those were the 3 connections we created using NMCLI. Now let's go back to ENS18, which is our interface, and hit edit. Here we can change the interface name, we can change the device that it's assigned to, and we can even go in and change stuff like the IP address, the gateway, the DNS server. We can add a domain for resolving requests locally. We can even set some basic routing and DNS parameters as well. So compare this tool, which is very useful, very easy to understand, to NMCLI. Why would you use NMCLI? So there are 2 use cases in which you would use NMCLI instead of NMTUI. The first is if you're writing a script. NMTUI does require interaction, so you can't really script it, but you can script NMCLI. The second is if you actually enjoy your own suffering. There are people with kinks like that. I'm not one of them, but hey, if you like psychological torture and you like putting yourself through the meat grinder for no reason, use NMCLI. Time for a quick data dump with Mr. Low Spec. Did you know there's a special folder that all your network connections are stored? I don't advise you actually go there and manually edit them, but you probably should know where that folder is. You never know when you might need that. That folder is located at etc Network Manager System Connections. Long ago in ancient times, before Mr. Low Spec was born, before there was even an internet, an ancient evil was unleashed upon the world, and that evil's name is DNS. Domain name system. Let's talk about it and find out why you will eventually hate it. First, let's talk about FQDNs. What are FQDN? An FQDN, otherwise known as a fully qualified domain name, is composed of 2 parts. There is your host name, and then there is your domain name. Your domain name is normally something like vlan.org. As a Linux administrator, one of the things you need to know how to do is to change your host name. And just like every other thing on Linux, there's about 3 or 4 different ways you can do that. Let's talk about a couple of those. Did you know you could use NMTUI to set a host name? Let's try that out. NMTUI, set a host name. We shall call this lab1. Hit OK. And then we have to set a domain. So we click edit, and then we can go down to search domains, and that is lsl.org. And there we go. And then we hit OK. And that's how you set a host name using NMTUI. There's a second utility we can also use to set host names. That utility is hostname.ctl. To configure hostname.ctl, we will do hostname.ctl, set host name, and we shall call this lsl1. Now, when we cat/etc hosts, you'll see it's now set to LSL. So what did we just do? We set our host name using hostname.ctl, and then we confirmed it got changed by reading the hostname file. That leads us to the third way to set a host name, and that is simply to edit the hostname file. So if we were to do echo lsl2 and then pipe that to /etc hostname, then we were to do cat/etc hostname, you can see our hostname is now changed to lsl2. So there are 3 methods to change your host name.